Hello, TCA students. Today we're going to look at a few of the special cases that you run into when you are factoring. The first case we're going to look at is factoring completely, which means that you might factor it the first time and then find that you can factor it again. So you always want to remember to check for a GCF first, a greatest common factor. Let's begin with problem A. Problem A has a 2, a 16, and an 18 as the coefficients. What number goes into all three of those? 2 goes into all three of those numbers. So the greatest common factor is 2. Notice not every term has an m, a variable. Since this last term does not have an m, I cannot pull out a variable. So I'm going to take a 2 from every one of these coefficients. This first one breaks down to 2 times 1, 16 breaks down to 2 times 8, and the 18 breaks down to 2 times 9. So the 2 comes on the outside of the parentheses, and then I'm left with 1 m squared plus 8m minus 9, because the 2 was brought out from every term. So I have factored out the GCF. Now I want to see if I can factor it again. This 2 on the outside just drops down. It's kind of like your little sibling, your little sister or brother who likes to tag along. This 2 has to tag along when you continue factoring. So now I'm going to see if I can break this trinomial into 2 binomials. So remember, we're going to look for 2 numbers that multiply to 9 and add or subtract to 8. So as I think about what multiplies to 9, I can do 1 times 9 or 3 times 3. Then I want to look at the 8. Can I add or subtract these numbers to get an 8? If I subtract 9 minus 1, I will get 8. So 9 and 1 are the numbers I'm going to use over here. 9 and 1. M is going to be my first term in both parentheses. So now I want to decide where my signs will go. It's a negative 9, so when I multiply I have to have 1 positive and 1 negative. But I want to add or subtract to get a positive 8. So that means I'm going to have to do a positive 9 minus 1 to get a positive 8. This is the end of my factoring. I cannot factor any further than that. So now we have finished our factoring. Now let's look at problem B. Again, the first step is to factor out the greatest common factor if possible. So I'm going to look at what goes into all 3 of the coefficients. I have the number 3, 48, and 189. 3 goes into all of those numbers. 3 times 1 is 3. 3 times 16 is 48. And 3 times 63 is 189. So my greatest common factor is 3. That can come out. Do I have a variable that I can pull out? Notice I have x to the third, x squared, and x. They all have 1x in common. I can't do 2 or 3 because that last term only has 1. I can only take the one with the least amount. So I'm going to pull a 3 out and an x from each term. So what's left from the first term? If I took out the 3, I have that 1 left. And I took one of those 3 x's, so that means I have 2 x's left. Then I have the plus. On the second term, I have the 16 left. I took one of those x's out of the x squared, so that means I have 1 left. Again, I have a plus. I took the 3 out, so I have the 63 left. And I took the x out, so I don't have an x left. So I did the first part of factoring out the greatest common factor. Now I'm just going to drop that 3x down and see if I can factor this trinomial into two binomials. So I want two numbers that multiply to 63, add or subtract to 16. So as I think about 63, I could do 1 times 63, or I could do 7 times 9. 7 times 9 adds up to 16. So I'm going to use the 7 and the 9. I'm going to need an x and an x for my first terms. Now I just need to decide on my signs. We have a positive when we multiply and a positive when we add or subtract. So that means I'm going to have the same signs, both positive, in order to multiply to a positive. And I'm going to end up with plus and plus because I want to add up to a positive 16. So now I'm finished factoring. So now we'll go to part B, difference of two squares. Difference of two squares is when the first term is a perfect square, it's something times itself, and the last term is a perfect square, it's something times itself. So notice I have x squared, that's x times x, and 25, that's 5 times 5. They're both perfect terms. Notice there is no x to the first power. Normally when we do our factoring, we saw like we had m squared and an m and then the constant that did not have a variable with it. When we do difference of two squares, it's only two terms, an x squared or variable squared and the constant. No term has an x to the first power. There is no x term, x to the first power term. Also, it must have a subtraction sign. If you're adding the two terms, this does not work. It has to be subtracting. So looking at problem A, we are subtracting x squared minus 25. One way to think about it is x squared plus 0x to the first minus 25. Those first two terms have to multiply to x squared. The last two have to multiply to a 25. Well, that's got to be the 5 times the 5 in this case in order to get a 0 in the middle. One's going to have to be positive 5, the other a negative 5, so that they'll add up to 0. And notice that x squared, x times x, gave me this x. The 25 is 5 squared, and that gave me these 5s. One positive and one negative to give me my factored expression. The second one is x squared minus 81. X squared is x times x. 81 is 9 times 9. So I'm going to have x for the first term in the parentheses, 9 in the last term of the parentheses, 1 adding and 1 subtracting. The positive 9 and the negative 9 will add up to 0 to give us a 0 term in the middle with the x to the first. On problem C, remember to check for a greatest common factor. 9 and 49 do not have a common factor. Nothing goes into both of those. So now I'm going to look at difference of two squares. 9 is 3 times 3, and x is x times x. So I could do 3x times 3x. Same number, same expression being multiplied times itself. Then think about what times itself equals 49. 7 times 7 equals 49. When I factor it, I'm going to have a 3x first. I'm going to have a 7 as the last term. One is going to be adding, and the other parenthesis is going to have subtraction. That would be my factored form. The third special case we're going to look at is the perfect square trinomial. Notice in this case, the first term and the last term are perfect squares, something squared. When we factor, we see that we use the a, which was squared, and the b, which was squared for the third term, in our parentheses. So look at problem A. The first term is a perfect square. It's x times x. The last term is a perfect square. It's 3 times 3. So I want to see if this works. Can I do x plus 3 times x plus 3? You always have to check these because sometimes the middle term doesn't work out. So we're going to check this with distribution. X times x, x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Notice those two middle terms add up to 6x. That's what I want in the middle. So it does work. X squared plus 6x plus 9 takes me back to where I started. So my factored form of the expression is x plus 3 times x plus 3, which I could also write as x plus 3, that whole quantity squared. Look at problem B. Again, the first term is a perfect square. It's 5x times 5x. The last term is a perfect square. It's 4 times 4. So I'm going to check to see if this works. 5x and 4, 5x and 4. But notice I need a negative when these middle terms get put together. So I'm going to want both of these to be minus. That way when I multiply the negative times the negative, I still get that positive 16. But when I add those middle terms together, I'm going to get a negative. Let's make sure we're going to get a negative 40. We need to check that. So I get 5x times 5x gives me my first term of 25x squared. That's right there. Then I'm going to do 5x times negative 4. That's a negative 20x. And now I'm going to take that negative 4 times that 5x. That's another negative 20x. And my last term would be a positive 16. Negative 4 times negative 4 is a positive 16. Check that middle term. Does it give us a negative 40x? Yes, it does. So that worked. I can bring down the rest of that to show that I have what I started out with. So my factored form is 5x minus 4 times 5x minus 4, which could also be written as 5x minus 4, the whole quantity squared. The next type of special case we're going to look at is the leading coefficient is negative. So what I'm talking about there is this right here. That had a negative with the x squared. This one has a negative with the x squared. This one has a negative 2 with the x squared. Whenever you have that leading coefficient negative, it's nice to factor out the negative 1 before you try to factor the polynomial. So what we're going to do is we're going to break this down. Think of it as negative 1 times a positive 1 gives me that negative 1 up there as a coefficient. This one is a negative 1 times a negative 8 in order to get a positive 8. And this one's a negative 1 times a positive 15 to get that negative 15. So if I factor out the negative 1 out of all three of those terms, that's going to come outside my parentheses. Then what am I left with? I'm left with a positive 1 x squared, a negative 8x, and a positive 15. Notice that all these signs just changed. I had a negative x squared. Now in here, I have a positive x squared. I had a positive 8x. It became a negative 8x. I had a negative 15. It became a positive 15. When you factor out a negative 1, all those signs will change. So now I want to see if I can factor again. Bring down the negative 1. He has to tag along when you're factoring. And then my first term is an x squared, so that's going to be an x times an x. My last term is a 15. So I want to think what numbers multiply times 15. 1 times 15 or 3 times 5. These need to add up or subtract to that 8 in the middle up here. So the 3 and the 5 work. And I'll need to do a -3, -5. They would multiply to give me the positive 15 and add together to give me the -8. Problem B. Again, I want to pull out a -1 and then change all the signs. That negative x squared becomes a positive x squared. The positive 7x, change it to a -7x. The positive 18, change it to a -18. Now, just look in the parentheses. I'll need x times x to give me that first term. To get the 18, when I multiply, I could do 1 times 18, 2 times 9, or 3 times 6. Can I add or subtract any of those to get a 7 in the middle? Yes. 2 and 9 can subtract to a 7. Which one needs to have the negative? The 9 needs to be a negative and the 2 positive. That would end up giving me a -7 when I add those together. That would be my factored expression. In problem C, I do have a leading coefficient that is negative, but I also want to see if I have a greatest common factor. So what goes into 2, 14, and 12? 2 does. This would be 2 times 1. This would be 2 times 7. And this would be 2 times 6. But I'm going to take out the -2 as my greatest common factor. So that will leave me with a positive x squared. This was negative, so it's going to turn into a plus 7x. So I need the 7 and the x. And then this sign was a minus. It's going to change signs to a plus. And I've already brought out the 2, so I just need the 6. Now bring down that -2. See if you can factor this again. X times x. 6 could factor to 1 times 6 or 2 times 3. Which one of those can add or subtract to a 7? The 1 times 6. So I'm going to need 1 and 6. And they're both going to be positives in order to multiply to a positive 6 and add up to a positive 7. Part E is the most difficult type of case to factor, in my opinion. This is where your leading coefficient is not a 1. So in problem A, we see that there's a 2 here. Always check to see if there's a greatest common factor with the 2 and the 9 and the -5. Does any number go into 2, 9, and 5? No, it doesn't. So I cannot pull out a greatest common factor. So I checked for my greatest common factor and I can't do it. So now I want to find the factors of A and C. A is the first coefficient, 2. 2 breaks down to 2 times 1. The second coefficient is 5, which is 1 times 5. So I have a couple of possibilities. To get that 2x squared, I could do 2x times x. And to get the 5, I could put the 5 here and the 1 here. Or if I keep that 2x and x where they were, I could trade the 1 and the 5. Put the 1 in the first parentheses and the 5 in the second parentheses. Now I just need to see, how do I get that 9 in the middle? Which one could give me a 9 in the middle? So I'm just going to check by multiplying. If I did the 2x times the 1, that's going to be 2x. The 5 times the x, that's 5x. The 2x and the 5x, do they add or subtract to a 9? No, they don't. So now I'll check the other pair that I listed down here. 2x times 5 is a 10x. 1 times x is a 1x. Can I add or subtract a 10x and a 1x to get that 9x? Yes, I can. So this is the one that I'm going to use. I just have to decide, where do I want my positive and my negative? I want to get a positive 9 in the end, so that means I want a positive 10 minus 1x. So to get the positive 10, I'm going to have the plus with the 5, and to get the negative 1x, I'm going to have the 1 be my negative. So my final answer is 2x minus 1 times x plus 5. And if you did a quick check on that, 2x times x is 2x squared. 2x times positive 5 is positive 10x. Negative 1 times x is negative 1x. And negative 1 times 5 is negative 5. Those middle terms combine to my 9x. So I'd get the 2x squared plus 9x minus 5, which is what I started with. Let's go on to problem B. First, check for greatest common factor. 7, 9, and 2. Does any number go into all three of those? No. There's nothing that I can factor out. So now I'm going to find the factors of A and C. The factors of 7 is just 1 times 7. Factors of 2 is 2 times 1. So the 1 and the 7 I'm going to put in my first position. 1x times 7x would give me that 7x squared. I'm going to make 2 of these because I have 2 options with that 2 and the 1. I could put the 2 in the first parentheses and the 1 in the second parentheses, or I could put the 1 in the first and the 2 in the second. Those are my only options. So now I have to check, how do I get that negative 9x in the middle? Check by multiplying. 1x times 1 is 1x. 2 times 7x is 14x. Can I get a 9 by adding or subtracting that 1x and that 14x? No, that one's not going to work. Let's check the second one. 1x times 2 is 2x. 1 times 7x is 7x. Can I get a 9x with a 2 and a 7? Yes, I can add those together to get a 9. So I just have to decide what my signs are going to be. I want to multiply to a positive 2 and add up to a negative 9. Looking up at the original problem, positive 2 and negative 9. So I need both of these to have the same sign, so they'll multiply to a positive 2, but I want them to add to that negative 9, so I'm going to do negative and negative. So my final answer is x minus 1 times 7x minus 2. For problem C, we're going to start by checking for the GCF, remembering that this is always your first step. Looking at the numbers 6, 14, and 4, I know that 2 goes into all three of those numbers. 6 is 2 times 3, 14 is 2 times 7, and 4 is 2 times 2. So I can pull a 2 out as a greatest common factor. I do not have an x in all three terms, so I cannot pull out an x. 2 is going to go on the outside, and then I see what's left. 3x squared is left for the first term. Then I have my plus. 7x is left in the second term. Another plus, and then a 2 is all that's left in that third term. Now I want to try to factor the polynomial that's left inside the parentheses, but I'm going to have to be careful to bring that 2 with me every time I move down to the next step. It's easy to forget that. As I look at the polynomial that's left in the parentheses, I see that I do not have a leading coefficient of 1. So I'm going to have to use the same process of finding the factors of A and C. The factors of 3 are 1 times 3. The factors of 2, 1 times 2. So I can begin with 1x times 3x. That'll give me my 3x squared. But I'm going to write it twice because I have two options. I can now take this 1 times 2. I can put the 1 in the first and the 2 in the second parentheses, or I could put the 2 in the first parentheses and the 1 in the second. But don't forget to bring down that 2 outside the parentheses. It has to tag along. So I'm going to check. 1x times 2x is 2x. 1 times 3x is 3x. A 2x and a 3x cannot give me that 7x in the middle. I can't add them or subtract them to get that. So check down here. 1x times 1 is 1x. 2 times 3x is 6x. I can get a 7x with that. I can add those together. So that's what I'm going to use. Since both of my signs are positive up here, that means I'm going to need pluses in both of these parentheses, because that way they'll multiply to a positive 2 and add to the positive 7x. Final answer, 2 times x plus 2 times 3x plus 1. So my method is a trial and error method. If you want to see an alternate method, you can click on this link, Factor Trinomials when a is not 1.